Hello everyone, just a very quick video here on what is density and how to calculate it. Now this, according to my Year 8 students, is actually one of the most confusing topics that they study. It's quite a straightforward one, so I figured I'd just do a very quick video just to really reiterate a few key points. Imagine we've got a Coke bottle on to the left. This is just to put all of this into a bit of a context. Got a Coke bottle on the left, and here's all smiley with your Coke bottle, and what you're going to do is you're going to put that into some water. You've got a tray full of water and you're going to put that in. And when you put that Coke in, what you notice is that it floats on the surface. So that Coke is floating on the surface of the water. Now that's a Diet Coke. If you imagine we had just a regular Coke, if we were to put that in the water, what you'd notice is that that actually sinks to the bottom. Now this is the opening question. This is the question I ask my own students. And I say, can you think, why? What might be going on? Why would one Diet Coke float on the surface of the water and one sink to the bottom? And it all really comes back to this idea of density. Density refers to how much mass there is in a given space, in a given volume. So two things really we need to consider in here: mass, and volume. Now there is a formula that links these two. Density is equal to mass divided by the volume. And if we put some units to this, density is measured in grams per centimetre cubed. The mass has units of grams, and the volume, as you might be able to guess from the density units, is centimetre cubed. And we can use letters to represent this formula, so almost like shorthand version. So we can say that D for density is equal to M divided by V. So you can see that what we're looking at is the amount of mass we've got in every given unit of volume. Think of it, some of my students say think of it a bit like a weight. It's not necessarily to do with a weight as such, but I guess it would mean that an object is kind of heavier. So in a given amount of space, if there is more mass, more material, it would be heavier in that particular bit of volume. So if we go back to our Coke example, Diet Coke, so the Diet Coke actually contains less sugar. So there's less mass in that fixed volume. So in the amount of volume that there is in that can, the mass is smaller. So if we look at our equation here, D equals M divided by V, if M is a smaller number, when you divide that by volume, you can see that overall the value for density would come out much smaller. Now, as it happens, the density of water has a fixed value. Water has a density of 1. So I'll just make a note of that. So water has a density of 1 gram per centimetre cubed. Now what that means, ultimately, is that if an object has a density greater than 1 gram per centimetre cubed, it would sink. So greater than 1 gram per centimetre cubed. What that would mean is the object would sink, and if it was less than 1 gram per centimetre cubed, the object would float. And that's what's happening with these two Coke cans. The Diet Coke is floating because there's a density value lower than 1 gram per centimetre cubed. Now we'll just do a few very quick examples, just using the formula essentially to kind of put this into another bit of a context. So let's go back here. Imagine we've got three materials. We've got three materials, A, B, and C. And what we're going to do is record for A, B, and C, we're going to record the mass. So we're going to say the mass of A is 40 grams. We're going to say the mass of B is 50 grams. We'll say the mass of C is 80 grams. So here we've got our mass. Now if we were to imagine the volume associated with these, so we've got three different materials, A, B and C, or imagine that this could easily be a class practical where you've been asked to work out the mass of each item using a balance, and then you've had to work out the volume of each item. Maybe if the item is cube shape, taken a ruler and measured its height, width and depth, or for an irregular shape, using a displacement can. But in any case, let's say we've worked out volumes as well as, let's say 10, 100 and 20. These are all in centimetre cubed. And these are all our volumes. Then essentially, using our formula, D equals M over V, so using this formula, for object A, do this here, for object A you do 40 divided by 10, so that would be 4 grams per centimetre cubed. We'll just do a little dash there to say that the units are the same. 4. For B, 50 over 100, that would come out as 0.5 grams per centimetre cubed. And for C, 80 divided by 20, that would also come out as 4 grams per centimetre cubed. The dashed line just means the same units. So we can clearly see that object A and object C would both sink in water because they have a density greater than the value of 1 gram per centimetre cubed. But object B has a density of 0.5 grams per centimetre cubed, so object B would be the one that floats. And there you have it, that's all there is to density. Density refers to the amount of mass in a given volume. Using the formula mass divided by volume, mass is in grams, volume in centimetre cubed, and so density would be in grams per centimetre cubed. And usually in the context of Key Stage 3, it's to do with objects sinking or floating, and it depends on what the density value is relative to that of water, water being the value of 1 gram per centimetre cubed. Okay, hope all that helps.